my electrolyte in a lithium-ion battery is lithium hexafluorophosphate. That's not a mouthful, is it? Lithium hexafluorophosphate. And back in the day, we were really worried about the fluorine that was coming off from it. When I start saying back in the day, I mean about 10 years ago. Lithium hexafluorophosphate. Lithium hexafluorophosphate is a solid. This is where we start getting into the lithium ion portion and understanding why lithium ion batteries are not water reactive, but lithium batteries are water reactive. Why is it called a lithium ion battery and what's going on with this electrolyte? That's where we're getting the lithium. Lithium hexafluorophosphate is my electrolyte that's a salt. It's a salt. Sodium chloride is a salt. Sodium metal, is that water reactive? Yes? Absolutely. Who gets a sticker now? I saw a head shake. I heard a yes over here. I can't run over there too fast. So, sodium chloride is not water reactive, but sodium is water reactive. Chlorine, really toxic. IDLH of 10 parts per million, right? This is bad stuff. You join them together, it makes your potatoes taste good and it gives you high blood pressure, right? Table salt. It's water soluble, right? It dissolves into the water, right? Dissolution. It separates into its constituents into the water. Lithium hexafluorophosphate, it's a salt. If it's a salt, it's not water reactive. It can be soluble or miscible. Lithium hexafluorophosphate is miscible with our flammable volatile organic compounds that are mixed into the electrolyte. So I take my solid, I put it into my carbon-based liquids inside the battery, and now it's a solute. Now my lithium ions can travel from my anode to the cathode as we go through this, right? An ion. Now, hazmat techs, Chief told you raise your hand. Raise your hand again, hazmat techs. You got nerds. Ionization. What do you got? I'm staring right at you right now. Ionization. Where have you heard ionization before? Think air monitors. PID, right? All right, I stared at you long enough, you get a sticker. There you go. A photo ionization detector. Our hazmat techs know about that. What does a photo ionization detector do, hazmat geeks? It knocks off the electrons from volatile organic compounds, right? It's ionizing them. Oh, prevention. Where's prevention at? I'll call you out. Where's my CRR? There we go, prevention. When you hear ionization, what are you thinking? Ionization. Smoke detectors. You're past, don't worry, you'll get your chance. Smoke detectors. Ionization. We have the element americium-241 inside the ionizing smoke detector, and it's always ionizing the electrons. And then the smoke blocks that ionization from happening, and that thing goes off. It's a super cheap version of a PID, right? So ions. Ions are changing of the positive or the negative of a chemical. We're taking lithium ions, we're knocking off electrons from my lithium ion. The ions are going and being stored, the electrons are being stored, the lithium ion, the positive lithium ion is going through my lithium salt solution, my electrolyte, and it's going to one other side, and now we have the potential, right? That's what's going on here. So I don't have pure lithium metal. I don't have water reactivity. And we all were thinking at the beginning of this, when we first heard about it, it's like, oh my God, they're lithium ion batteries. They're water reactive. They're not water reactive. There's water reactive as table salt. That's not the problem here. So we got to get a little bit deeper. Yes, I'm getting chemistry into you guys. I have to do this really quick. We're not talking about moles and other things like that. Guys, I did horrible in chemistry. I'm just understanding just basic chemistry theory, right? When we go into this, what is the issue? Go back to that volatile organic compound. It's carbon-based. Can it be flammable? Sulfuric acid, not flammable. Potassium hydroxide, not flammable. Lithium hexafluoride, not flammable. Flammable VOC. Flammable. It has the word in it, right? Two other things before I get off this slide. Things that you need to know. State of charge and battery management system. You need to understand those terms as responders, as members of the community. Understand I know what state of charge means. What's my battery percentage at? It's at 82% right now. That's what a state of charge is. Hey, what's the SOC? So nerds start talking about it and they just say, hey, what's the state OC? You need to ask the reporting party and you need to identify from the equipment what the charge is, because the charge is going to tell you how much potential energy we have throughout this event. Chief Stevens, he ended up getting this analogy from Captain Chris Green when they were up in Fort Worth. It comes on down to, if I sit there and think about a bunch of pallets, I stack pallets out in this room, I keep them horizontal on the ground. Can I light them on fire? Will they light on fire? Yes. Will that fire travel and grow really quickly? Not really. It's just going to travel. If I put them all together and I stack them upright and I end up stuffing hay in them, I put gasoline, diesel, other things on them, is it going to have more energy, more potential energy? Is it going to take off more quickly? 100% state of charge versus 30% state of charge. There's still energy potential, it's just slower to be released, right? And this is all taken care of by that battery management system, that little chip that's in our battery. It controls the electricity, it controls the charge. It'll turn individual cells off if it starts identifying that they have problems. It will identify a lot of things. A good BMS. We've had freaking lithium-ion batteries forever. How many cell phone issues have we had other than the Samsung Note 7? Not many. The BMS in these things are amazing. When you get to that $330 scooter, BMS, not so good, right? That's the issue.